Alright, so today I wanted to make a quick video about some of the improvements I made to my golf cart. I live in a large neighborhood. A lot of folks have golf carts to get around and visit folks, use the facilities in the neighborhood, etc. So one thing I noticed that with electric golf carts is obviously they require maintenance, right? The batteries require maintenance. You have a limited lifespan, right, depending on driving conditions and whatnot. This is a 2015 Easy Go, and it does have a 36-volt battery system, as you can see here. You'll notice that all of my interconnecting cables have been supersized, if you will. When I first got the cart, I don't know, about 6 months ago, it had all the interconnecting cables were much smaller, I think 6 gauge, and what that did was it provides a point of resistance to where some of your power is wasted just trying to flow electricity, from one cell to the other until it ultimately gets to, the wheels, driving the wheels, the vehicle via the motor. So, and I noticed that I'd come back from, a trip around the neighborhood or whatever, and, anything over 5 minutes, 10 minutes, some of the cables would be warm, like physically warm to the touch. And to me, I'm an electronics technician from way back, and that indicates a problem. Something's undersized, something's not connected properly, something's not designed properly, etc. If you have high heat on a connector, something's not right. Some of the cables would get so hot that you couldn't even hold it. So over 160, 180 degrees, somewhere along in those lines, if you had a heat gun, which I didn't. But anyway, I decided to address it, and I'll give you a little more detail about that. So I went ahead and took the seat off. Easy to do, just fits in these little tabs there to access the batteries. I guess to start off with explaining a little bit about how an electric golf cart works. Here's my charge cable. I have it out here for this purpose today. Charger's inside the garage. So basically you take this cable and I come over here and I plug it into. Alright, so the charge port has those two wires coming out of it, mainly the white and black one, right? And it runs along there in a conduit, and it goes one side to the negative, positive post of the battery here, and the other goes to the negative post. Basically what you have, again, the total voltage is 36. So these are all 6-volt batteries individually, right? And 6 times 6 is 36, so they're connected in series. Basically, as I just showed you, the circuit goes from this wire through the cells to this battery, out of the battery into the next battery, across to the other battery, and then so on and so forth until you get back to this part, right? And this is just the charging circuit, but the discharge circuit is not much different. So some of the other components of the system would include this silver box back here. The silver box back here with the heat fins, or cooling fins I should say, that is it's a heat sink for the purpose of managing heat for this black box here. The black box is your control module. Okay, what does it control? It controls how much amperage is delivered via those cables that you see down below back to the motor, right? There's your drive motor back there, right? And you have 4 cables going to that, right? So if you didn't have if it was just a direct connect, it would be a direct short from the batteries via, whatever switch mechanism you decided to use, whether it's this throttle pedal or whatever the case may be, you would dump full battery amperage to the motor back there, and I'm sure cause some havoc and destroy some things. Couldn't have that. So the control module is for that purpose, right? So the foot pedal, right, goes to, the controls go through this solenoid here, right? So you have a 12 volt control signal from a foot pedal that causes the solenoid to open and close the circuit, right? And the circuit would be this cable here to this cable here, right? That's going through the solenoid when the plunger is drawn down and connects the two posts, right? And what that does is it's a break in the circuitry between the battery, the load, and this control box that I mentioned earlier, right? So when you press on the pedal of a golf cart, you'll hear a little click before it moves or does anything, right? And that little click is a solenoid functioning, right? You can't apply any power, any of this battery voltage cannot be applied to the drive motor in the back without going through that control box, right? And it goes into the control box and out into the control box, I guess, from the solenoid. That's a gate, basically. And I want to talk about this component next. This component, it's fairly large, but it's the actual forward and reverse switch. So I was just talking about the forward and reverse switch, right? What that does is it changes the polarity, right? By changing how the contacts are shifted from one set of wires, to another set of wires. It changes basically the polarity of the voltage that hits the motor right through the other circuitry we just mentioned, right? That's how you go from forward to reverse, because you have a DC motor powering the drive axle, and a DC motor, turns in a direction that's specified by the voltage, right? So what I mean by well, I'm not going to get into that. So I'll just show you that how that works is you have this mechanical linkage here. This switch, right, controls this linkage that controls that shift, which controls the contact surfaces. And the contact surfaces, you could see them right there, engaging and disengaging, right? So if I go to reverse, I believe it's in reverse now. And if I switch it to forward, one set of contacts are connected. If I go to reverse, it bridges across two other contacts, right? So so all of that basically makes up the drive and control circuitry of a DC voltage, a 36 volt DC golf cart, right? Now, some of the issues that you can have, let's talk about that. You could have issues ranging from, a bad power supply or charger connector, right? This heavy duty plastic connector, that 2-pin connector, it's female to male, and it can get loose over time, brittle, it can break, there's a spring inside that holds pressure against the pins. If you look down there, it's a connector that makes additional pressure to have a firmer connection when you plug it in. So that could break or bend or lose tension over time, and that could cause a potential issue. Poor connection. So, and generally, poor connections are probably one of your largest concerns. If your switch is going bad, the aforementioned switch here, right, and it starts to get loose, either you know, between those contacts I mentioned earlier, you're gonna increase the resistance, and anytime you increase resistance, especially in a DC circuit, you're losing power, right? Because it has to increase the voltage and amperage to jump across that same connection. So you're going to lose power, and typically you're going to see that as heat. So these will actually, if they have loose connections or going bad, this will get so hot that these will actually start fusing and turn dark brown and then black, and you'll smell things when you're driving around. I know that because the one I had before was on its last leg. We'll just put it that way. So in a general sense, you want to make sure all of these connections, every single connection, right? This, right? All of those connections, all of these connections are tight, right? Tight as though when I put pressure here up and down, I can't move anything. When I put side to side pressure, you know, it's fixed, right? That's going to ensure that all of your amperage gets across with a minimal amount of resistance, and that's good because that's going to equate to longer drive time, right? And generally longer life for your batteries, right? These are lead acid batteries, by the way, right? And they do require servicing and monitoring, right? That's how you check the electrolyte level, aka acid. That will boil out over time. So now that I covered that, you have a better understanding of the components that make up the 36 volt DC circuitry of a electric golf cart, right? So I will add that I don't know why they originally wired these with such small gauge straps, battery straps, and interconnects. I don't understand why they do that. Well, I do. It's cheaper, right? Because with copper connectors and conductors, obviously the larger the more copper, and it just drives expense. So, but these are well worth it, right? I wanted to get the largest diameter that I could get for this application and still be manageable. And by manageable, I mean fit in the spaces, and you obviously have to bend them to where they are in the proper orientation. The larger cable you get, the more difficult it is to shape it and bend it to your needs, and it's just a handful. You also want to upgrade other things if possible, like the solenoid, to make sure your solenoid is of the highest amperage capacity, right, for your purpose, right? Whether it's 120 amp, 130 amp, 200 amp, whatever the case may be, you want to make sure it is the largest amperage solenoid, because again, it's constant amperage flowing across that when you're driving, especially when you're driving steady state. If I spend 10 minutes driving, from here across the neighborhood, then that's 10 minutes of amperage, right? Just constant direct current, high amperage going across the thing, and they will heat up, right? So now, do I still get any heat now? A little. The direct drive, the cables that go back to the motor, specifically for forward, because you got a pair for forward and a pair for reverse, and again, that's dictated. Which ones are connected to the batteries are dictated by the switch that I mentioned, right? One position connects the forward pair to the battery voltage, and then the other position connects the reverse pair, right? So it's probably a dead horse at this point. The whole switch as a whole stays cool now. For the most part, all the interconnecting cables stay cool. If I drive it hard over a long period of time, and I mean like an hour, I'll start to feel a little bit of warming, and a couple of the cables that specifically go back to drive the motor, but a little bit of warming, not hot, just so it's getting a little warm. But again, that's after 30 45 minutes, maybe an hour of usage. The solenoid will get warm, right? It'll get pretty warm. My guess would be probably 130, 140 degrees. It's not so hot that you can't touch it, but it does get pretty warm, which might mean that's still a little bit undersized for this application. But again, everything has been far improved over its original, OEM condition. All right, so where did I get the cables? Right now on Amazon, you can buy complete 36 volt golf cart rewiring kits. Right, so it'll come with a bundle of cables. I don't remember exactly how many it takes. It's, probably a dozen cables that come with a kit, and they're of various lengths. And the idea being, it's they're kind of pre-cut and pre-terminated cables that are pretty much a bolt-in install. Now, I didn't go that route. I got my cables through Amazon for the most part. I did get a few from Tractor Supply here and there. But I wanted them, specific links, not just the links that I saw came with the kit, for my purposes. And I ordered, 4 of these, 2 of these, 2 of these, or whatever, different links till I got the the configuration or the amount of cables that I needed to complete my upgrade. Right. So, and again, most of my cables are 2 gauge, not 2/0. 2/0 is even much larger than this, but 2 gauge. You can see them. If you want to go look at them in person before you purchase any, you can see battery lead cables and things like that. Usually at like a Harbor Freight or Tractor Supply. And Harbor Freight, they're usually marketed as inverter connections, inverter leads, intended to connect high output inverter for like RVs or things like that. But they'll be 2 gauge typically, and maybe as long as 60 inches. Anyway, I 2 gauge was, I thought, large enough to do the job, as evidenced by the fact that they no longer get hot. Maybe 4 gauge would have done it. I don't know, but more conduction is better than less. So 2 gauge was still bendable. 1 gauge, it would also probably work, but again, it's a lot thicker and a lot tougher to bend around. And I wouldn't even think about 1/0 or 2/0. If you go look at some hardware store, you'll see what I mean. One more thing I wanted to add before I end the video is, I should have said this up front. 1, remove all watches, rings, and jewelry when you're working around electricity. Right, I should have done that. I did not do that. That's a problem. Don't do that. Secondly, as I said before, this is a 36 volt system. I explained the circuitry of how the cells are all connected. These are all 6 volts. This is 6 volts, 6 volts, 6 volts, 6 volt, right? You add them all together, which they are added together because they're connected in series, right? Positive, negative, and so on and so forth, until you get to, the load, if you will, and makes up a total of 36 volts, right? So some folks you see have replaced all of these lead. These are heavy, by the way. These are just as heavy as a car battery, you would think, because they're 6 volt. They're huge, right? The physical size are every bit as maybe bigger than some car batteries, and just as heavy. And altogether, you just imagine how much that, all 6 of those weighs, right? I'm guessing, probably 500 pounds. I don't know what they weigh individually, but it's a lot. Some folks, as an upgrade, replace this entire battery system with 1 lithium-ion battery pack. I haven't priced that. I know it's pretty pricey, over $1,000 from what I've seen. To do that, is it worth it? Maybe. I'm not sure. But folks typically do that. They also replace the controller module back here to be able to use more of that, available electricity in a more efficient fashion. So it's typically not just the battery people upgrade. It's other things, and it gets pretty pricey. So will I consider that? Yeah, I'll consider it, but in the meantime, I want to get as much life as I can get out of lead acid batteries, and make sure I properly maintain and use them for the duration of their life. Alright, so we've got the seat back on. We're gonna shut her down, and well, that's going to conclude my video on the golf cart electrical system, and I hope you got some good information out of this. And if you have any questions, just hit me up in the comments and I'll see if I can figure it out. Alright, until next time, thank you.